Hello and welcome to yet another episode on the White Dog Garage YouTube channel. My name is Bob. In this episode I'm going to be making a sheet goods carrier. Sheet good carriers are for carrying sheet goods like plywood, like drywall, but can also be useful for carrying doors and tabletops and all sorts of large rectangular things that are not particularly thick. And I've recently found the need for one. I'm going to make two, in fact, because I have the need for two, and I've got to have an assistant, and I thought I'd take you along on the making journey. Sheet good carriers come in two basic types. One grips at the top of the sheet, like so, and the other one grips at the bottom of the sheet, like so. And the idea being that you carry this way or you carry this way. The top grip is going to be fiddly, having an adjustment to counter for different sizes. There's always a problem if something is just a bit too heavy. So I'm going for underneath. That way it's supported from underneath. The carrier is going to be made from steel, so there's going to be no giving way and no slippage. I've done a drawing which I will provide you with a close-up of. Some critical measurements, and probably you need to understand why I've chosen particular measurements. It's being made out of essentially 50 by 50 by 3 angle. That's about 2 by 2 by 1/8 of an inch in imperial measurements. The drawing here, I've listed dimensions, and you're most welcome to use them, but you probably need to understand where those dimensions come from. So we'll start here at the bottom. I have made my bottom bracket 50 millimeters wide inside. That's 1 inch and 15/16 approximately in imperial measurements. The reason I've chosen that size is that I'm going to use this to carry doors which are 35 or 45 millimeters wide in Australia, as well as sheet. You might want to make that smaller depending on what you think you might want to carry. So essentially, as the bracket goes up, the side arm goes up, it goes up 350 millimeters here, and then kinks in at a 45-degree angle and ends up at 70 millimeters across the top, and makes the overall dimension along the side before you bend it of 420 millimeters. 350 plus 70 millimeters. That's 13 and 11/16 of an inch to there, and then another 2 3/4 of an inch for the remaining piece. Now, the reason I've chosen that is that suits my height. I'm 6 foot tall, 183 centimeters, thereabouts. I would probably think that I would carry some of the stuff upstairs, so I need it to be a little higher off the ground. If you were just carrying sheets from your vehicle on a flat ground, you might want it to be a little longer. I have made, and this is a 20 millimeter or so diameter pipe that's running across here. I've made it 150 millimeters or 5 7/8 of an inch wide, and the reason for that is that fits my hand, and I've chosen the 20 millimeter pipe because that is a nice grip on my hand. Your hand is probably different, and you could choose a thicker pipe or a thinner pipe based on your personal preference. And the reason I've chosen to come in 70 millimeters here, or 2 3/4 of an inch thereabouts, is that again that brings my knuckle away from where the sheet will sit on that line. I've already pre-cut and assembled my materials. As I say, there's going to be 2 of these made. They're going to have a channel base that whatever I'm carrying will sit in. I've cut these, and I'll show dimensions in a drawing, but I've cut these and these will form the sides. This is all 50 by 50 angle, 3 millimeters thick, so it's 2 by 2 by 1/8 of an inch thick. And I have cut 2 lengths of tube which will form the handles. So the basic design of these is to have a flat section that sits against the sheet, and then to come back at an angle where you have the handle. I have dimensioned this for my hand, my big fat hand, and I have worked out that I need to have this bend back at that angle. The easy way to do with angle iron like this is just to cut a relief and bend it across. Now, what's the angle? Well, I've worked out that I need the centre of my handle to be here, and I've just come down an equal distance, so that angle in there is 45 degrees. A line is 180 degrees, straight line, that's the total angle. 45 from 180 is 135 degrees. So essentially we need to remove a 45 degree segment from the side arm so that we can bend it up and get that necessary bend that we need in the carrier. Now, there's a couple of ways of doing this, and I'll show you probably the wrong way and the right way. So 45 degrees and the remaining angle is 135. We could just cut out this segment here, 45 degree segment, so there's a 90 degree there, so it's 45 in there. Cut that out and then bend it up so that that joins to there, and then weld it. Unfortunately, and I've drawn this a little bit bigger than scale so that you can see it, but unfortunately you end up with a much longer side there against this one, and when you weld it up it just looks wrong. So you could hit it with the grinder and sort of smooth out so that it sort of flows, but that's not the best way to do it. The best way to do it is to cut out a triangle around the 90 degree perpendicular so that when you remove that triangle, force it up together, the sides are equal. And the way you do this, and if you've watched a few of my videos, particularly my fabrication videos, you'll hear me talk about half angles. So the angle we want to end up with is 135. That's going to be the bend. And 135 divided by 2 is 67.5 degrees. So what we do is we mark our perpendicular, we draw a line 67.5 degrees from one end of the perpendicular on one side, and then we draw a line on the other side, 67.5 degrees. That difference in there is 45 degrees. We cut out that triangle, we bend them together, we come up with this. The two joining sides are both equal lengths, 67.5 degrees, 67.5 degrees, so our ultimate angle is 135 degrees. It is a much neater join, and it is the proper way to do it. The distance down here is 70 millimeters, or almost 3 inches. So the first thing I do is mark it down 70 millimeters. then I put a line at right angles. I've set my protractor to 67.5 degrees, and I centre that here because we're making the cut this way, and I draw one line there. I turn it over, move it up, and I draw my other line there. So what happens is I'll cut out this section and bend it in. You have to remember you've got a left and right, and what that means is that you'll have one which is essentially the mirror image of the other. So if you got there, and that one will go there like so. So essentially like that. One reflects the other. I recently bought myself a bar bender, and that's what I'm going to use today, but equally you could use a hammer and a vise. So what I've done is I have welded these two offcuts to the table, basically to hold the bracket in position, to get the angle the same from bracket to bracket. I've got to pack it out. we're ready to make the channels now. It's a relatively simple thing to make. I want to have my channel 50 millimeters wide. I've just got a 50 millimeter square hollow section, just an offcut. I just drop it in, so that's my 50 millimeters. Whack a clamp on, keep it all in place, and weld it up. Final assembly stage now. So that's the base. Two arms, a little spacer here, and then I set up for the handle, and I'll come back and show you what it's like clamped up once I just square it all up. So we're all clamped up now, ready to go, time to weld. Okay, there we go. Pretty well finished. Just got to get a coat of paint on them and they're ready to use. We go back to our dummy sheet. It sits in there like that, and it's probably a better perspective. we go. We're ready to haul. So, I hope you enjoyed the build, and if you did, welcome a thumbs up, and of course, share it widely, it's all good. And if you haven't already subscribed, I welcome your subscription, and I will be talking to you next time.